Good morning. Today we start doing stuff in RStudio. We start with the actual course and not just the preparation. And to start off with, I will guide you through the GitHub Classroom invitation and how to clone your GitHub repo to RStudio. And that is something I already showed in the last video, but I will show it again here. And hope it will be helpful. Maybe I will show it tomorrow too in the next lecture, just so you have some repetition. But the first thing you have to do is you get this GitHub Classroom invitation link, which will be in the YouTube video description, but also participants of this course will have it sent to them via email and via Slack. And then you click on this link, and then it will, you have to accept the classroom invitation. I already did it, so I cannot show this without deleting the repo first, but then you just have to accept it, and then it will automatically configure an online repo based on the template I gave it. And then you receive this link here to your repo. Of course, you need a GitHub account to do all of this. And then you can take a look at your repo. This is the repo we will be using today. Here you see what's part of the repo. Here is usually displayed the readme.md file, which is an overview file in Markdown. So it's not in R, it's in Markdown, which is a formatting language or a formatting syntax. Unfortunately, I didn't have the time to set anything up with the readmes here, so it's just empty and you can ignore it. Then we have this license file, the licensing agreement under which this repo is distributed should be GNU, GPL 3.0 license. Then we have git ignore, which you can just ignore. We have this pull request for feedback, which we won't use, so you can ignore it too. And then we have the important parts, which is our R script for today, which is called guitar D1 individual tasks R. And then we have this little part here, which is just the R project. And this exists, I think this won't exist for you, but it exists for me because I already pushed stuff into this repo. So if it's not there for you, then don't panic. Everything is all right. Okay, and now we want to clone this repo to our computer using RStudio. And the way this works is you press this green code button and copy the code, the HTTPS address that is put in here. There's a button to do this. And then you switch to RStudio. Now we are in our RStudio window. You go into File, New Project, Version Control, because we are building our project from version control, Git, and then you have to enter your repo URL, which we just copied. And then here you can set a path where you want to save your local repo into. In my case, I've set up a folder called GitHub repos in my D drive, and you should do the same. Set up a folder for this, and then save all the local repos for the individual tasks inside of this folder. But I don't have to change it now because I already set it up. And then we just click on Create Project, and it will automatically clone it. There we go. It takes a little bit, takes a while. All right, and now we have cloned our project, and we can see the files we had on GitHub down here in the folder structure. We will talk a bit more about what's going on with the files later. But first, I think we should talk a bit about the user interface. of RStudio, because I think you just see it for the first time or one of the first times, and you're not really familiar with what's happening here. And user interface, just so you know, you can refer to as UI, which is just the abbreviation, or GUI, 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 which stands for General User Interface. It's just everything you see here, everything that enables you to interact with the software. So every button, every tab, and so on, every little window you see here is part of the user interface. So the first thing you may have noticed, if you have a fresh, a clean install of R, your RStudio might not look dark. It doesn't have a dark background like mine. This is just an aesthetic choice. I prefer to look at a dark mode, so dark background and then bright text, as opposed to a bright background and dark text. This is just personal preference. If you agree with me on this, you can go into Tools, Global Options, Appearance, and there you will find a bunch of settings regarding the layout of this software. There's a bunch of preset themes you can choose from. I think I don't use ambience. I think I use this one, Idle Fingers. Not entirely sure, but it doesn't really matter. I just prefer the dark background. And then you can also set the font size and the font. All right, so that's just for your information. And then some people have asked me what's the difference between RStudio and R. If I open the normal R general user interface, which you can just do by simply typing R down here in your search window and then opening the application called R, you see it looks a bit different. It looks a bit maybe older and outdated. This is of course in German now, but this is the normal user interface R is distributed with. You automatically download this too if you download RStudio, and you can work in R in this user interface just fine. So maybe to show you, I'll do this just to show that it works. So you see we've written hello world into X and called X, and it showed up just fine. You can technically work with this, but we use RStudio because RStudio is a so-called IDE, which stands for Integrated Development Environment. And it basically just means it's an environment that's made to make your life a bit easier. It has tons of tools for debugging, for reviewing code. It has a bunch of integrated functions, like these little tabs here, to make it easier for you. You can, for example, clone repos from Git using Git, which is something we used before. You can't do that in the normal art, or you can do it in the normal GUI, but it's way more complicated and requires a lot of manual input. And you have a bunch of other stuff that is quite good to, especially for beginners, to make your life a little bit easier. But yeah, let's go back to the user interface of R and talk a little bit about what's where and where to find things. And you can see here you have 3 windows. If you don't have anything open, if you have a script open, I can open the script for today, for example. Then you have 4 windows, and these 4 windows are probably the one you will be looking the most at. So I will briefly explain what these 4 windows do, what they are for. You can adjust the window sizes by drag and dropping the individual parts around. Maybe it's a bit depends on your monitor, and in which window you work the most with. Usually you need a larger left side than right side, so I will keep it like this. And then we do like this. I think this is a good distribution for the windows, but do whatever. This part here is where our script is displayed. The script is basically a bunch of code that is saved inside of a file, as opposed to code that is just run in the console and then disappears. So if we write code here, we just do the exact same thing that we did before in the GUI. And save the script, then our code will be saved. So I just said, if you write code into the script and save the script, your code will be saved. It's like any other document. It's how you mainly how you write your code and how you save it. And this is opposed to writing code in the console. So down here you can see you have a console, and the console shows the results of what you're running and error messages and warning messages. But you can also write code directly into the console. Like this, and then execute it. It works just fine, but you cannot save what you've written so far. So we barely write any code inside of the console itself. We usually write it into the script, so our code is preserved. And also another reason why we do that is that we can use comments. And you can see a lot of comments in the script already. So all of these, for me, they look a bit like gold colored, but for you, they might look different. It changes with appearance, the theme you've selected. So these lines with the little hashtag symbol, the double cross, they are comments, and that means if you run those lines, they will not give anything to the parser, so they will be ignored. So if we write our code into the comment like this, and then run it, nothing will happen. And this is very important to comment out code that you don't need. So deprecated code, for example, you can just put if you don't want this anymore, you can put it the comment symbol in front of it, and then it won't run, and you don't have to delete your code. You can still like know that this is something you did before, but you don't need it any longer, but maybe you need it in the future, so you leave it there. And another use of comments is to explain what you're doing. So in this case, we are assigning a string to a variable. And I very, very much recommend that you comment everything you're doing when you're a beginner, just so you know. If you close this script and come back, I don't know, 2 weeks later, you will have forgotten maybe. If it's a long and complicated script, you will have forgotten what was happening there. And I think comments greatly help to explain that. All right, so we will talk a bit more about how to run code and how to work in the script later. But for now, let's move on to the environment. The environment is up here. It's this little window. Of course, there's a couple of different tabs. The tutorial one gives you hints on how to complete the inbuilt RStudio tutorial. There's a package called Learn R, and then you can go through this tutorial and like try to learn R. But we won't do this in this course because we do our own stuff, so it's kind of irrelevant to us. The Git tab is probably the second most important part of this little window here for us. We will talk a bit more about pushing and pulling data. I think you already know what the little Git window does from the last video. I think I showed how to commit and how to push using this window. Connections isn't important for us. History shows what we have been executing so far. So it's kind of the history of our code execution. In our case, we have run this assign hello world to X, and then we have shown X. So run X. This is exactly what happened down here. You can see here in orange, this is basically the history. That's also in our console. So if you have run a lot of code and you don't want to scroll up through the console to look at your history, you can look at it here. But I barely ever use this function of RStudio. And then the most important part is our environment. The environment is basically where stuff is stored as long as you are in the RStudio session. So you can see here we have one value called X, and inside of this value is a string called hello world. And this showed up here before when we ran this code. So if I assign a new variable called Y and call it welcome to GitR22 and assign this, you will see it will show up here. So this is just so you have an overview over values that are stored by RStudio. You can save this environment, but you can also just reproduce this environment. If you close R and open it again, it will not be here anymore unless you saved it. If you don't save it, it's not really bad. You can just rerun your script and then everything will show up here and be readable by R. All right, so this is our environment. It's very good to keep track of what we have been doing and what files are registered, so to speak, by RStudio. And then down here we have a couple of different tabs. We have files, which shows us, it's basically the Explorer from Windows. Right now it's inside of our repo, and we can navigate our repo in here, but we can also go back to the entire folder structure of me. Then we have the little plots window here. This is where your plots will show up, or your maps. If you plot anything, it will show up down here. So if you try to visualize anything, it will show up down here. You have a couple of options what to do with these plots. You can zoom, you can export them as image or as PDF. Then we have the package tab, which is where all the packages you have installed show up. Packages, sometimes called libraries. In other programming languages like Python, you would refer to them as libraries, for example. So don't be confused. It means the same thing. Are libraries of code that was written by other users, and inside of these libraries are a bunch of functions to do specific things that aren't possible by base R. So if you really want to, you can write your own functions and create your own libraries and then share it with the world to extend the functionality of R. So maybe a geographer's metaphor would be to compare these packages with maybe plugins in QGIS or ArcGIS. Yeah, here you can see what packages you have installed and what version they are on. And you can also activate them manually, but we will do it using a code command, a function. So you don't really have to pay too much attention to what's going on here. Then we have the help window, which is very, very important for us. But you will never have to open this yourself. If we use the help function on anything, help, and with help, I mean the documentation of R regarding the function you've used the help function on will show up down here. So for example, if I use help, sequence stands for sequence. It's a function. It doesn't really matter. You don't have to understand right now. It's just so you see how this help window works. If you run this line, it will show up the corresponding part of the documentation, and there you can see how this function works, what it does, the description, how you use it. So there's always an example, and what arguments does it have. We'll talk a bit more about what arguments are and how functions work later. But this is quite important. Just so you know how to get help. You can get help inside of R. You don't have to leave it and look this up in the documentation yourself. And then we have this viewer window, which we never use, so we will just ignore it for now. Okay, but these are our individual parts. And now we can start, I think we can actually start using R and trying to write code. And I will delete our environment because we don't need it anymore. It was just to show you, show a couple of things. And you can see here we have our script for today, which is what we will be working with today. And you can see all of it as comments. So if we run this entire script, nothing will happen. You run code by either using this little run button here, and then selecting the code you want to run, like this. It showed up in our console because it's a comment, but it didn't run anything. Nothing happened. It just showed up down here. So you first have to select the code you want to run, and press this run button. Alternatively, and I think this is much more preferable, you can use a hotkey combination, Control plus Enter. So Control plus, where's plus? Here, Enter to run a line selection. If you do not select stuff, Control plus Enter will run the line you're in. So if you're here, it will run the line 5. If you're here, it will run the line 6. If you're here, you will run the line 7. And you should always put this little cursor at the end of the line before you run it. So let's just run this. And then you see down here, it runs this line and shows us the comment. Personally, I'd recommend working on dark backgrounds, but it's up to you. All right. So this is how you run code. If you want to run your entire script, you can also use, I think, this button, source the contents of the active document. But you barely ever use it, or at least I don't. All right, you could also put it to source on save, then it will run when you press the little save button down up here. Yeah, so there's a couple of different options on how to run code. I personally prefer using Control Enter, because if you use it, it will jump down to the next part of code anyways. So you can just go through by pressing Control Enter a lot. All right. So what do we have here? Here's just how to change the appearance. I already talked to you. I already taught you how to do this. I recommend working on dark backgrounds because it's, in my opinion, easier on the eye, especially if you stare at code for long. Then we have this little comment here saying the hashtag denotes comments, which I already taught you as well. And then we have something that's quite interesting and I think quite important. Of course, how much code you can read in one line varies between users, and it depends on how large your font is, but also on how large your screen is and how large you made this window. So you should keep that in mind when you write code. And the idea here is that we do not want to exceed a certain line size, and we do not want to format it like this because it's very badly readable. So RStudio gives you this vertical line here to kind of tell you where to cut off your lines. So you shouldn't go over this line unless it's absolutely necessary. which sometimes if you use a read-along file path, for example, there's nothing you can do about it. It goes over this line and it becomes hardly readable, but that's how life is. But if you can, try to use a lot of line breaks to keep the lines short and precise. Yeah. All right, let's continue with some more stuff. And I think before we start assigning something to a variable, we should clarify some vocabulary. So there are 3 or 4 important things you should know and keep in mind when working with code in R. So there's a couple of terms you should know. The first one is variable. The second one is operator. And the third one is function. And these 3 terms are basically our bread and butter when it comes to R. This is how we code. A variable is something that stands in place of something else. So you know this from maths already, technically what a variable is. But in the programming context, a variable is something we assign a certain value to. So in the very first task, we are supposed to assign a string to a variable. A string means characters, so words. And this is we've done this before to have an example for code. But if I create a variable called hello world, and I can give any name for a variable, it doesn't matter, I can call it X, Y. In our case, we call it hello world because we write hello world. Here's one tip for variable names: don't use abbreviations because you will forget what they mean unless they are established abbreviations. So something like QGIS, for example, is an established abbreviation. You can use this and you will remember it. Or something like centimeters and meters, units, for example, are very established. But don't create your own abbreviations because you will forget what they mean, and you don't want to put a legend into the comments every time you write some code. So if we do this, we have 2 out of our 3 terms used. This is our variable. This is what we write into. So this is what we the value we assign, the variable we assign something to. This is the operator. The operator in this case is the assignment arrow. And in R, you use an arrow to assign an arrow to assign something to something. You can also use other signs. In other programming languages, you often use the equal sign. I think this one is also possible. And little fun fact, you can use the assignment arrow both ways. You could also do this and assign into the other direction. It doesn't make any difference. It will still work and run the same, but we don't do this usually. We write the variable name first, like this. Oops. And what will happen if we run this line? We will assign the 2 words hello and world, and that is called a string. And you will always see that something is a string by these little quotation marks here. So these little quotation marks denominate text. If we do not enter these, I will assume these 2 are numbers and will give us an error if we try to write it, or it will assume it's an object. An object means variable. So in our case, let's add this to the variable. Okay, so we need the quotation marks to denominate a string. Okay, but what happened here is we have created a variable called hello world, which you also see here up in our environment. And inside of this variable is a string, so 2 words, hello world. And now every time we call this variable hello world, it will show us the content. It refers to the content, which is hello world. So if we just write it into a line and run it, oops, it will show us hello world. All right, and now we could keep working with this variable, but something that's missing here is a function, and I think we just move on, and then you will see what a function is. So here we didn't use any function, we just assigned this little character string into a variable. We could also just do a bunch of numbers, or let's just call it a number, and then take 42 and write it into a variable. And now we have a variable called a number, and inside of this variable we have the number 42. You could also write simple maths into this. 42 plus 12. We assign it, and then you can see here inside of this variable we now have the number 54, which is 42 plus 12. You could also run a function in this, and this is something we will do if we move on, and that's why we move on right now. But let's delete this for now. So you can write all sorts of different stuff into a variable. You can write digits, you can write text, which are called strings. You can write files, images, and functions into variables. And here we do a little line break because this is starting to get too long. There we go. This has to be a new sentence. And to assign an object to a variable, you use this assignment arrow. I told you this. To start off, we do exactly what we did here. So I already did it a bit before. I just copy down this code. I didn't call the variable X, but really the name doesn't matter. I think hello world is a better naming convention here. So let's change it in the comment. Once you have defined a variable, they appear in your environment. So these are the variables remembered by R. And once they are in your environment, you can freely call them by just typing their name and running this. Yeah. Once again, I will move it into the 2 separate lines. I know you notice your executed code is displayed in your console down here. Now we can check the mode of our variable hello world using the mode function. And this is the very first time we use a function. And a function always looks like this. It has a name, and then it has brackets, parentheses. In our case, we use the mode function. And the way this works is you first put in the function name, and then you put into the brackets, into the parentheses, the arguments of the function. And we can maybe get a bit more help on the mode function if we use the help function on the mode function. So if we write help and then use put in the name of the mode function here, it will open up our documentation down here. I've showed you this before. And it says mode is part of the base functionality of R. It's called mode of an object, and it gets or sets the type or storage mode of an object. And the way you work this is the way you use this, the way it works. The way it works is you use the function called mode, and then inside of the brackets, you put the variable you want to use it on. And this function has two arguments, x, which can be any R object. In our case, that is our variable called hello world. And value is a character string giving the desired mode. So if you want to override the mode of an object, you could also do this, but we don't do it yet. So for us, the only important argument here is x, which is what we are using now. So now you've learned how to use this function. And usually the very first argument in any function is the object you want to use the function on, the variable you want to use the function on. Yeah. So let's run this and see what happens. So if we run mode on hello world, we receive down here in the console an output, and it says character. And this makes sense because these little words here, they are made of characters, right? So it makes sense that the object mode is character because we are looking at characters, as opposed to a number, for example, which would be numeric. If you, for some reason, want to save the mode somewhere, you can also just do it like this. That's called mode hello world. So if we run this, it will assign the result of this calculation of this function into a new variable called mode hello world. There we go. And now we have up here in the environment a value, a variable called mode hello world, and inside of this variable we have character. And now if we use, it's getting a bit meta, but now if we use the mode function on mode hello world, we will find that this little word here, character, is also made up of characters. So this is just a little side information, but you can easily write the results of your functions into new objects and keep working with them. And sometimes it's very important. And all right, but here's a parenthesis missing. If there's an error, if there's like a bracket missing or something, RStudio will tell you here. It gives you a little warning. So you need to fix it before you run it. Character is not the only mode variables can be stored in. So obviously that would be pretty lame, and we couldn't do any maths if we could only work with characters. Another one would be numerical, which are numbers, and then Boolean or logical, which is true or false. So if we create a new variable called, let's just keep with the naming conventions here for now, because I don't want to change them in each comment. So if we create a variable y and we assign this variable true, it has to be in capital letters. If you write like this, it won't work. But it will suggest that you use true in character in capital letters. And if we create a new variable, let's run this. And if we create a new variable z and give it enter 42 and run it, we have created two new variables. And those two variables have different modes. If we, for example, run mode y now, we will see that the mode of our variable is called logical. And logical means true or false. So it's binary mode that you sometimes need. You don't have to write the entire true. If you're really lazy, you can also just write T. We run this, and it works. It's still logical, and you see up here, and our variable y is true. So you could also write true. Alternatively, you can write false. It's a logical, or f, which is logical. Same thing. And then down here, we have the other variable called z. And if we check the mode, we will see the mode of this variable is numeric, because inside of this variable is a number. And now it's interesting to see what happens if we combine these two modes, right? If we try to add the two. Okay, so let's try to combine the two variables and see what happens with the mode. So create a new variable called xz, assign x plus z. And you can see I'm doing little empty spaces between the individual digits and operators. And this is to improve the clarity of the code. So technically it still runs if you have it like this, but it's very crowded and hard to read. And also the assignment error like this, it looks like smaller than -x, in my opinion, and it's very confusing if you have longer mathematical operations. But it's kind of up to you, but please be consistent with your styling conventions. So if you never do this, don't just do it in some line, just do it never. If you always do this, then you have to do it always. So in my case, I would have to do these little empty spaces always, and that's what I'm doing. So yeah, if we run this code, we will get an error message, and the error says object X not found, and that is because I was very mistaken and that we wanted to combine. We were supposed to combine X and Z, but because I renamed the variable X into hello world and kind of went with it, now we don't have an object called X, but we can easily fix this by creating it and assigning it our variable, because we have the contents of X. We just have to assign it our variable. There we go. And now we have a variable called X. You can see it up here, which is basically just a copy from our variable hello world. I can delete this now because I now have the object in my environment, so R remembers it. And if we try to combine those two, we will get an error message called error in X plus Z, non-numeric argument to binary operator. So this is kind of what we would expect. We have a binary operator, which is Z, which is numeric. And then we have X, which is a character, if you remember, which is hello world, so words. And it tries to add the numbers to the words, but it cannot because it's different data modes. So this is something you might have to keep in mind if you work with data sets. You cannot, or you have to kind of take care to have the correct modes on your data. So for example, we could also store this 42. By default, it's stored as numeric, but we could accidentally store it as character, and then we couldn't do any calculations with it anymore. So this is something you have to keep in mind. Some data modes are not, do not go well with each other. Then we are supposed to use a new function called sec, which stands for sequence. So it's short for sequence, the SEQ. And first, we will get some help on this function. Here it doesn't really matter if you write it with quotation marks or without. It works both ways. And then you can see down here in the documentation, sec is a function used for sequence generation. It generates regular sequences, and this is not important for us. It generates regular sequences. And the way that, this works is you write sequence and then some stuff into the parentheses, and inside of the parentheses you have a couple of arguments. And we have three important arguments we will talk about. We have the argument from, the argument to, and the argument by. And the arguments from and to should be pretty self-explanatory. It's where your sequence starts and where it ends. And then the argument by is the number of steps that will be undertaken to fill out the sequence. So this will become more clear if we actually try it. We create a variable called sequence 0 to 70, and we assign it the result of our function sequence. And now we have to kind of sort this out with the arguments from 0 to 70 by 7, because we want it in 7 steps. And if we run this, we will see it generates the new variable sequence, and inside of the sequence is numeric. That's what num stands for. So it's numbers in there. We have 11 entries from 1 to 11, and the entries are 0, 7, 14, 21, 28, 35, 42, 49, 56, and so on. Or if we just call it down here, we can see more of it. There we go. So this is our sequence. And if we generate the sequence by 3 steps, then it will be much larger. It will look like this. But we want it like this. All right. And here's an important thing that you should remember. R knows the order in which arguments are supposed to be given. So you don't have to name the arguments. You could just get rid of the from, of the to, and the by, and it would still work as we want it to work, because the order of these arguments is set in stone, basically, and it remembers it. So as long as the first argument is your from value, the second is your to value, and the third one is your by value, you're good to go. So this generates exactly the same thing. Another way to create a sequence really fast is by using the double dots, but this only works if your sequence is regular. So if it's a 1, if all of the steps are by 1 and not by 7. So if we run this, it will produce an error message saying error in sequence default from must have length 1. But if we get rid of the by steps and have it like this, then you will see we just get a sequence from 0 to 70. And this has 71 entries because we started from 0. Okay, but this is not what we want now. Sorry, this is not what we want now. So we get back. So now if you want to find out the length of our sequence, we can look it up here in the environment. You see the length. It's from 1 to 11, so it has 11 entries. But you could also use another function called length, which is very self-explanatory. And you just give in the length of the object you want to the length of, and it returns the length, which is 11. So we have 11 entries inside of our sequence. But now to something that's probably more important. and that is indexing, because often we want to a certain value out of a sequence or out of another object. It doesn't really matter if it's a sequence or anything else. But what if we call what if we want the 7th value out of the sequence? So we could go ahead and like count 1, 2, 3, 4, 5, 6, 7. So we know the 7th value is 42. And then we could write it down and work with it, or assign a variable called 7th value. And give it 42 because we know it. But what if we have something that's more complicated than a sequence? Then it gets really hard. Or what if the sequence is really long and we can't count it anymore? Then we can index. And the way this works is you give the name of the thing you want to index, and then you give rectangular parentheses, and then you give 7. And then you receive the 7th value out of your sequence, 42. So every time you see these rectangular parentheses instead of the round ones, you know this is an indexer. It's indexing some value inside of your data set. It doesn't really matter. Every time you see it, it's very important to remember. But what if we want to call 2 values at the same time? Then we kind of have to perform a little magic by using a function called C, which combines values into a vector or list. We will talk more about data types later. So vector or list would be data types, and we will talk about them, I think, tomorrow even, so pretty soon. But for now, you just need to know that this combine function combines values. And if we want to call this 2nd and 6th value at the same time, we have to call this our sequence and then the rectangular parentheses again, and then we use the combine function and give it our 2 values that we want. Oops, like this. Maybe like this. And then we get the 2nd and the 6th value in a list, which is 7 and 35. And conversely, we can do the same for the 4th and the 8th value, just by changing these names, these numbers, not names. And then we get 21 and 49. And if we look into our sequence, you can count and find out it's correct. We'll find out it's correct. Okay, but what if we want to overwrite one value inside of this sequence? Then that's also very much possible. In the same way, we would assign a value to a variable just by calling sequence 70, indexing the 3rd value, and then assigning something new into it. And we can assign anything. Let's assign a string, which is weird, right? It's not a number. We assign basically the word 3rd into the 3rd value of the sequence, and see what happens to the sequence afterwards. So now our sequence will look a bit different. Now you see around each value within the sequence, you have these little quotation marks, and the quotation marks, as you remember from before, they denominate strings. So now the mode of our sequence, or the mode of the mode of the values inside of the sequence, to be precise, is character. So because a sequence cannot have more than one data mode, the mode of all data inside of the sequence was now converted to character to accommodate for the single 3rd we put into there, which is a character, right? All right. So that's something you have to keep in mind. There are data types that support multiple modes in it, but not this one, not the sequence. Okay, but that was already it for the very first lecture. Today we don't have an individual assignment. Your individual assignment is to go through this code and like try to sort it out by yourself. But down here I've put something called good coding practice, which is just my personal opinion, but that's a couple of things you should keep in mind when you work with code. Yeah, use the assignment arrow instead of the equal sign. That's a very baseline styling convention on how to use R, because sometimes you will use quotation marks instead of mathematical operations, and then you will get confused if you have quotation marks as an assignment arrow replacement. So in every styling guide for R, you will find the recommendation to use this assignment arrow, even though when you come from another programming language, it might not be super convenient for you. Then the second one is don't use abbreviations as variable names. I've said this before, but just don't do it unless it's a very, very, very simple and obvious abbreviation or something that's very established. Don't do it because you will forget what your abbreviations mean. And if you go back to your code later, you won't be able to read it. Comment your code, comment everything, especially if you're a beginner. Now we didn't have to comment it because I put the little assignments here, and they basically tell you what's happening in the line, what's supposed to happen in the line thereafter. But if you write your own code, comment everything, because you will absolutely forget what code does if you're not familiar with the programming language. Then use the help function, which is self-explanatory. Every time you learn a new function, use the help function on it to find out what it does. You don't need to use this help and then the brackets. You could also just question mark and then the function name, something like this, and it works just well too. If you don't want to clutter your script, you can also just run this down here in the console, then it won't show up in your script, but still work. Yeah, use the help function as often as you can. Stay away from empty spaces. That doesn't refer to the styling here, but if you name a variable, for example, and you call it something like sequence 70 with a space in between, R will not recognize it as one variable. So your variables have to be connected either by underscore or by just right in between or by a normal. Or this will be read as a minus sign. And don't use special characters exclusive to your language. In German, this would be stuff like Ü, Ö, and Ä, and sharp S. Don't use that ever, because programming languages aren't optimized for every language that exists. They are usually optimized for the English language. So try to stay away from those characters. They will cause you issues if they are in variable names, if they are in file names. If you use them within functions, sometimes it doesn't work, and then you can't figure out why it doesn't work. And it's just something as simple as you use the character that's not recognized by this function. Keep your formatting tight and readable by using a certain style. You can look up style guides if you want, if you're really into styling. For me, it's like this. I do line breaks between individual functions. Later, I will also cluster functions together if they are part of the same assignment. So if this assignment would require us to use more functions, I would write them like this and then make a line break in between to separate them from each other. But yeah, try to keep your formatting tight so you can read this code easily. Don't go over this line. Use frequent line breaks. Use frequent line breaks. And that's that. Okay, but I hope you had some fun. I hope you learned something, and then tomorrow we will continue with other more complicated stuff. So take your time to try this out, play around with what you have here a little bit. Yeah, be bold, make mistakes, and then see you tomorrow.